students, welcome to Akshar Academy YouTube channel. In this session, I am going to discuss thermal properties of matter, calorimetry. In this numerical problems, part 1. If you like this video, please subscribe to our channel. Please share your valuable comments in the comment section. Okay, let us go to the today's session. First one. A metal block absorbs 4500 calories of heat when heated from 30 degrees centigrade to 80 degrees centigrade. Its thermal capacity is. Here we have to calculate the thermal capacity of metal block. Let us go to the solution. Given here metal block absorbs 4500 calories of heat. So that is dq is equals to 4500 calories and temperature difference is equals to 80 minus 30. So that is equals to 50 degrees centigrade. We have to calculate the thermal capacity, that is ms. So heat gained by body is equals to heat gained by body is equals to, that is dq is equals to ms dt. So thermal capacity is equals to m into s, that is equals to dq by dt. That is equals to dq they given as 4500 and dt they given as 50. 0 0 gets cancels, 5 ones 5 nines are 0. So its thermal capacity is equals to 90 calorie per degree centigrade. Okay, next we will go to the next question. Three different substances have the specific heat in the ratio 1:2:3 and the temperature increases in the ratio 3:2:1. When the same heat is applied to the three substances, the ratio of their masses is. Here we have to calculate the ratio of masses. Now let us go to the solution. Given ratio of specific heats, S1 is to S2 is to S3 is equals to 1:2:3 and their temperature increases in the ratio, that is delta 1 is to delta 2 is to delta 3, that is equals to 3:2:1 and we have to calculate ratio of masses m1 is to m2 is to m3. So dq1 is to dq2 is to dq3, same heat is supplied, so that is 1:1:1. So dq is equals to ms delta t. This is ms or ms dt. Here m is equals to from this dq by s into dt, dq by s into dt. So ratio of their masses m1 is to m2 is to m3 is equals to dq by s1 dt1 is to dq2 by s2 dt2 is to dq3 by s dt3. Now substituting values, 1 by 1 into 3 is to 1 by 2 into 2 is to 1 by 3 into 1. So this is 1 by 3 is to 1 by 4 is to 1 by 3. So the ratio of m1 is to m2 is to m3 is, that is ratio of their masses are taking LCM 12 by 3, 12 by 4, 12 by 3. So this can be written as 4 is to 3 is to 4. Okay. Next we will go to the next question. In this question, the specific heat of a substance of mass 0.1 kilogram varies with the temperature T according to the empirical relation, that is S is equals to A plus BT, where A is equals to 1 joule kilogram inverse Kelvin inverse and B is equals to 4 into 10 to the power of minus 2 joule kilogram inverse Kelvin to the power of minus 2. The amount of heat required to increase the temperature 27 degrees centigrade to 227 degrees centigrade is. Now let us go to the solution. Given mass of a substance M is equals to 0.1 kilogram and the empirical relation they given as S is equals to A plus BT. A is equals to they given as 1 joule kilogram inverse Kelvin inverse and B is equal to they given as 4 into 10 to the power of minus 2 joule kilogram inverse Kelvin to the power of minus 2 and T1 27 degrees centigrade nothing but converting into Kelvin adding 273. So 27 plus 273 300 Kelvin. T2 is equals to 227. 227 plus here again 273. Adding for 227 273. 273 plus 227, that is 500 Kelvin. Now we have to calculate the amount of heat required. So dq is equals to integration of dq is equals to integration of T1 to T2 ms dt. So that is equals to m of integration of T1 to T2 s into dt. Now substituting dq is equals to m nothing but 0.1 integration of T1 to T2 s nothing but they given as formula A plus B T of dt. So dq is equals to 0.1 of integration of T1 to T2 A dt plus integration of T1 to T2 B T dt. So dq is equals to 0.1 A of integration of dt T limits T1 to T2 plus B integration of T dt T square by 2 limits T1 to T2. So that is equals to 0.1. Substituting A and B values in this, we get 1 into applying the limits T2 minus T1 plus B of B nothing but 4 into 10 to the power of minus 2 by 2 limits T2 square minus T1 square. 2 1s 2 2s. So this is equals to 0.1 of T2 minus T1 plus 2 into 10 to the power of minus 2 T2 square minus T1 square. Now substituting T1 and T2 values in this, we get, now substituting dq is equals to 0.1 of 1 into, that is 500 minus 300 T2 minus T1. So 500 minus 300 plus 2 into 10 to the power of minus 2 of 500 square minus 300 square. Now this is equals to 10 to the power of minus 1 of 200 plus 2 into 10 to the power of minus 2 half. Here this can be written as 25 into 10 to the power of 4 minus 9 into 10 to the power of 4. So 10 to the power of minus 1 of 200 plus 2 into 10 to the power of minus 2. This can be written as 16 into 10 to the power of 4. So this is equals to 10 to the power of minus 1 of 200 plus 16 to the 32 into 10 to the power of minus 2 into 10 to the power of 4. So this is equals to 10 to the power of minus 1 of 200 plus here 10 to the power of minus 2, 10 to the power of 4, 10 square. So 32 into 10 square, 3200. So dq is equals to 10 to the power of minus 1 of total 3400. So this is equals to 10 to the power of minus 1 nothing but 1 by 10 into 3400. 0 gets cancels, 340 joules. So the amount of required, that is dq, is equals to 340 joules. Okay. Next we will go to the next question. A geyser heats water flowing at the rate of 3.0 liter per minute from 27 degrees centigrade to 77 degrees centigrade. If the geyser operates on a gas burner, what is the rate of combustion of fuel? If its heat of combustion is 4 into 10 to the power of 4 joule per gram. Let us go to the solution. V is equals to, they given as 3 liters, that is equals to 3 into 10 cubic centimeter. Delta T is equals to 77 minus temperature difference, that is equals to 77 minus 27, that is 50 degrees centigrade. They given as here S is equals to 4.2 joule per gram. L they given as 4 into 10 to the power of 4 joule per gram. M2 by T we have to calculate rate of combustion. dq is equals to ms, amount of required, is equals to ms into dt. So dq nothing but here ml is equals to m1 s dt. So m2 by t is equals to m2 by t is equals to m1 s dt by T into L. So this can be written as rho 1 V1 S dt by T into L. Now substituting 1 into 3 into 10 cube into 4.2 into 50 by 4 into 10 to the power of 4. 10 cube here gets cancels, and here 3 5 are 15, 15 into 4.2 by 4. So that is equals to 15.75. Approximately this is equals to 16 gram per minute. 16 gram per minute. Okay, 15.75. Approximately we are writing 16 grams per minute. Okay, next we will go to the next question. How much heat is required to convert 8 grams of ice at minus 15 degree centigrade to steam at 100 degree centigrade? Now let us go to the solution. Here converting ice to first 8 grams of ice at minus 15 degree centigrade to steam at 100 degree centigrade, minus 15 degree centigrade, 0 degree centigrade, and now converting into water, 0 degree centigrade, and water now 100 degree centigrade, and finally steam 100 degree centigrade. Okay, now Q1 is equals to M S ice into delta T1, that is equals to 8 into half into 0 minus of minus 15, that is equals to 1s 2 4s, 4 into minus of minus plus 15, 15 4s are 60 calorie. Next Q2 is equals to MLF, latent heat of fusion, that is 8 into 80, 80 into 8 640 calorie. Q3 is equals to S specific heat of water into delta T2, that is equals to 8 into 1 into 100 minus 0, so that is equals to 8 into 100, that is equals to 800 calorie. Next, now we are calculating Q4. So Q4 is equals to M latent heat of evaporation 8 into 540, that is equals to 4320 calorie. Total heat required is total heat required is Q is equals to Q1 plus Q2 plus Q3 plus Q4, so that is equals to 60 plus 640 plus 800 plus 4320, so total 5820 calorie, or converting into joules 4820 into 4.2 joules, that is equals to 224,444. This can be written as 2.4 into 10 to the power of 4 joules. So amount of heat, total heat required Q is equals to 2.4 into 10 to the power of 4 joules. Now we'll go to the next question. Certain amount of heat is given to 100 grams of copper to increase its temperature by 21 degree centigrade. If the same amount of heat is given to 50 grams of water, then the rise in its temperature is specific heat of copper is equals to the given as 400 joule per kilogram Kelvin, and the specific heat of water they are given as 4200 joule per kilogram Kelvin. Now let us go to the solution. Here dq1 is equals to dq2, that is m s dt1, that is equals to m s dt2. First one required heat is for copper, and other is water. So now substituting values 100 into 10 to the power of minus 3 into 400 into 21, that is equals to 50 into 10 to the power of minus 3 into 4200 into delta T2. So this can be written as 2 into here 51s 52s 10 to the power of minus 3, 10 to the power of minus 3 gets cancels. So 2 into 400 into 21 divided by this 4200. 0 0 0 0 gets cancels. 168 by 42. So this is equals to delta T2. So delta T2 is equals to 2 4s are 8. 21 into 8, 168. 168 by 42. That is equals to 4 degrees centigrade. 42 ones, 42 fours. So delta T2 is equals to, therefore delta T2 is equals to 4 degree centigrade. Okay. Next we will go to the next question. When 500 kilogram of water is heated from 20 degree centigrade to 100 degree centigrade, then increase in mass of water will be. Here we have to calculate the increase in mass of water. So how much increasing, here we have to calculate. Now let us go to the solution. dq is equals to m s dt. So this dq nothing but delta m c square is equals to m s dt. Increase in mass delta m is equals to increase in mass delta m is equals to m s dt by c square. Now substituting delta m is equals to 500 into 4200 into temperature difference they given us 80 degree centigrade by 3 into 10 to the power of 8 whole square c square, that is equals to 5 into 42 into 8 into 10 to the power of 5. Here 1 2 3 4 5 0. So that's why we are writing 10 to the power of 5. 3 3 is 9, 10 to the power of 8 whole square, 10 to the power of 16. So this can be written as delta m is equals to, here 1680 into 10 to the power of 5 into 10 to the power of 16 by 9. Here 10 to the power of minus 16. So delta m is equals to 1680 by 9 into 10 to the power of 5 into 10 to the power of minus 16. 1680 by 9 after division we are getting 186.6, that is 10 to the power of, here 10 to the power of 5 minus 10 to the power of 16 minus 10 to the power of 11. So delta m required mass delta m is equals to, this can be written as 1.87 into 10 to the power of minus 9 kilogram. Okay. So required mass delta m is equals to, we are getting 1.87 into 10 to the power of minus 9 kilogram. Okay. Thanks for watching this video.